Hello friends, welcome to Academic Heights. Learn from home. Why Academic Heights? For clarity, for concepts, for core, for competency. Overall, your turning point starts here. I am ready to teach you. Are you ready to learn? Hello students. We are discussing chapter 6, triangles, class 10th. Most of the students they feel very hard this chapter because many exercises we have, many questions we have, and different concepts we have to apply different situations. To avoid this misconceptions clearly, we have to understand each and every concepts. We have to apply the applications where it is required, and a good practice, enough practice is required for this chapter. Then this chapter we will also score 100%. Today we are targeting 6.1 exercise. Before we start 6.1 exercise, we have to talk about similar and congruent. Many children they have misconception in similar and congruent. So what is similar? In similar we talk about only shape. Two shapes are same. In congruent we'll talk about two conditions, sizes as well as shape. Both are same. So similarity symbol, this is a symbol I have shown. This is a symbol for similarity and this is a symbol for congruent. So I have shown here two pentagons. Shape is same, but size matters here. Different in size. I have shown two hearts here. Shape is same. This is also heart, that is also heart, but sizes are different here. That is we talk about similar. Congruent means size and shape both are equal, both are same. So I have shown two pentagons here in the same size. I have shown two balls here with the same size and same shape. So this is about congruent figures and similar figures. By seeing only we can get the similar and congruent figures easily, but in depth if you go, we'll have some conditions to talk about similarity. So we'll see that further. Next, a beautiful example for similarity here. I have shown two squares. Both are squares but different in size. This is a side of 2 centimeters, that is a side of 5 centimeters. I have shown two equilateral triangles, different in sides. One equilateral triangle with 2 centimeters, another equilateral triangle with 3.5 centimeters. So sizes are different here. So two quadrilaterals are different in size. So this is a one of the example for similarity. Next, for congruent. So congruent means same in size and same in shape. So we'll have four examples here. We'll talk about line segments. If the two line segments have same length, suppose this is 10 centimeters. If this is also 10 centimeters. This is I'm talking about AB line segment. Here it is PQ line segment. But both are in same length. Then these two line segments are congruent. About angles. If two angles, the measure is same. Measure of angle E. In the figure you can see measure of angle E is 63. The measure of angle A at A also it is 63. The measure of angle A is also 63. So both are equal to 63. Then these two triangles are angles are congruent. These are congruent angles. We talk about two squares. These two squares are congruent because the sides of each side of a square is same. If this is 5 centimeter, this is also 5 centimeters. 5 centimeters, and this square is also have side 5 centimeters. So both are congruent figures. And we talk about two circles. If the radius of the first circle is equal to the radius of the other circle, if not, the diameter of the first circle, the diameter of the second circle is equal, then these two are congruent figures, congruent circles. If the radius of the two circles are equal, R1, radius of first circle is equal to radius of second circle, then these two circles are congruent circles. So we have given 4 examples here about the congruent. So let us see other questions. Yeah, this is a real life question. If we visit the photo studio, the photographer will ask that which size of photo you required. So here we have 3 different sizes I have shown: stamp size, postcard size, as well as passport size. So you have to identify which size is the appropriate here. So stamp size, so which is very less in size, this is stamp size. Next, passport size, this is your passport size. Next, postcard size, this is the last one, is postcard size. So I have shown different sizes here, and this is a beautiful example for similarity. In real life, we will have stamp size, postcard size, passport size. If you are applying for your admission, new admissions in a school or college, definitely they will ask passport size of your photo. So similarly, for your birthday, whatever you take the pics, so that is in postcard size. Why? Because of most of the people, they prefer postcard size to keep in the album. Sometimes we cannot identify these two are similar figures or congruent figures. We need a proof of that, whether these are similar or whether these are congruent. So on similarity, one of the experiment they have done, and they have checked that what is similarity in depth, what are the different points we have to study in depth, then only we can say that the two figures are similar. So in this experiment, they have a quadrilateral ABCD. They have holded ABCD quadrilateral. It looks like a trapezium. And top of that, they have taken a light. When the light passes through this quadrilateral, they have captured the image A dash, B dash, C dash, D dash. So this is the experiment they have done. So whatever they have holded, so same image they got it. Same image they got it. Here they observed two important things. What they observed? The corresponding angles are equal. Means A and angle A and angle A dash are equal. Angle B and angle B dash are equal. Angle C and C dash are equal. Angle D and D dash are equal. So this is the first observations of this experiment. Means when two figures are similar, their corresponding angles are equal. One more observation they got it. They have checked the lengths of each and every side. In a quadrilateral, we have 4 sides. So they have taken the 4 different sides of the ratios. A dash B dash by AB. They have measured A dash B dash as well as AB length. So surprisingly, they are getting a constant A dash B dash by AB. When they divide these two ratios, they got surprisingly one ratio. Maybe it is greater than 1, or maybe it is less than 1. If it is greater than 1, the image is larger. If it is less than 1, the image is smaller. So A dash B dash by, I will write better here. So what they got, A dash B dash by AB ratio they have found out, as well as B dash C dash by BC ratio, they got it, as well as C dash D dash by CD, as well as D dash A dash by DA. Surprisingly, they got this ratio is some constant, is equal to same constant. All four sides, the ratio is equal to same constant. So by this they understand that when two figures are similar, the sides are in proportion. What do you mean by proportion? Maybe one side is twice of other, maybe one and a half times to other, 3 times to other, 5 times to other, maybe 1.2 times to others, whatever it may be. So they got a relation between the sides. So they understood that sides are in proportion. So this is the similarity experiment. They have got two inside. One is corresponding angles are equal. Corresponding angles are equal. This is first point. And corresponding sides in proportion. This is they have deduced in this experiment. I hope it is clear to everyone. Next. So whatever in this experiment, they have taken the points that two polygons of same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. So whatever they got the two observations, so that is talking about this one. Next, so I have shown here two figures. You have to identify are these are similar or not. So look at, we have two quadrilaterals here. ABCD is a one quadrilateral and PQRS is one quadrilateral. So we have different sides in ABCD. Here also in PQR also we have different sides. Do you have any relation you found out between sides? So this is 1.5 centimeters and this is 3 centimeters. Clearly this side is twice of this one. And 2.5, it becomes, now it is 5. Clearly it is again 2 times. 2.4, clearly it is 4.8, again it is twice of this one. And 1.2, it is clearly twice of this one, it is 4.2. So each and every side is doubled here. Means the corresponding sides are in the same ratio, if not proportion. Same proportion. Every side is 2 times to the other. So that is one important point. What about angle? Angle A is 105. What about angle P? It is also 105. Angle B is 100. Angle Q is 100. Angle C is 70. Angle R is 70. Angle D is 85. Angle S also 85. So corresponding angles are equal. So it is obeying two conditions here. Corresponding angles are equal, corresponding sides are in proportion. So that these are two similar figures. Definitely we can declare that quadrilateral ABCD similar to quadrilateral PQRS. So this is the conclusion we got it as from this observation. We'll go to the next. Suppose, check these two figures. Suppose all angles are equal here. In the first figure, all are 90 degrees. All angles are 90 degrees. In the second figure, also all angles are 90 degrees. Means it is obeying the first condition. What about second condition? The sides to be proportion. Suppose I will take PQ by AB ratio. So 3.5 by 3. And I will take QR by BC ratio. This is clearly 3 by 3. So 3 by 3 it is 1 and 3.5 by 3 it is greater than 1. So clearly these ratios are not in proportion. So that these two figures, whatever you are saying, ABCD, quadrilateral ABCD, it's not similar to quadrilateral PQRS. Why? Because of it should obey two conditions, but it is obeying only one condition. The sides are in not in proportion. So clearly we can discard this one. These are not similar. So what about this one? So by seeing the shape only we can discard this one. These are not similar. Still, which conditions it is not obeying, we have to cross check it. If you check the sides, 2.1 becomes 4.2, means clearly it is 2 times. Again 2.1 becomes 4.2. So each and every side is twice of the other. So 2 times it is double clearly. Means the corresponding sides are in the same ratio. Means this condition it is obeying. What about the first condition? In the first condition, all corresponding angles should be equal. So here it is 90°, but here it is not 90°. Why? Because of there is no symbol about it. So here all are 90 degrees. So this is a rhombus. Opposite angles only equal. Opposite angles are only equal, but here all angles are is equal to 90°. Means first condition it fails here. So these two figures are not congruent. Next question. So we'll solve now whatever the idea we have discussed about the similar and congruent figures, as well as similarity. How to check the similarity? If I say two figures are similar, it obeys two conditions. Their corresponding angles are equal, their corresponding sides are in the same ratio or proportional. So based on this, we can conclude that those are two figures are similar figures. Now let us see the exercise 6.1. Fill in the blanks using correct words given in the brackets. All circles are. Definitely circles in the shape wise both are same. This is a circle, that is also circle. So all circles are similar. It's not congruent. All circles are not congruent. If the radius are equal, then it is congruent. He did not talk about the radius. So all circles are similar. What is similar definition? The shape is same. This is a circle, that is a circle, that is also a circle. So these are similar figures. All squares are. He didn't talk about the size of the side. So all squares are similar. All squares are similar again. It will be congruent when the side of the first square is same as side of the second square. Then only we can say it is a congruent. But he did not talk about that sides. Just he is talking about only squares. All squares are similar. Next, come to the third question. All dash triangles are similar. Is it isosceles triangles or is it equilateral triangles? Yes, all equilateral triangles are similar. Why? Because of all angles are equal and their corresponding sides are in proportion. In equilateral triangle, all three sides are equal. In the other equilateral triangles also three sides are equal. Somehow they maintain the corresponding sides in the same ratio. So here it is, all equilateral triangles are similar. Come to the fourth question. Two polygons of the same number of sides are similar if their corresponding angles are dash and their corresponding sides are dash. First one is it is equal, corresponding angles are equal, and come to the second fill in the blanks, that is proportional. So I hope it is clear. All circles are similar, all squares are similar, all equilateral triangles are similar. Two polygons of the same sides are similar if their corresponding angles are equal, their corresponding sides are proportional. Come to the second question. Give two different examples for similar figures and non-similar figures. So look at this example. Here I have shown two equilateral triangles, but the sizes are different here. Suppose I am taking this is 3 centimeter each and every side is 3 centimeter. Here it is each and side is 5 centimeters. So clearly all angles are 60 degrees. All angles are 60 degrees here. Why? Because of it is equilateral triangle. Here also all angles are 60 degrees. Now these are two equilateral triangles. Definitely these are similar figures. These are similar figures. Why? Because of corresponding angles are equal. Corresponding sides are in the same proportion. Each and every side maintaining 5 by 3, 5 by 3, 5 by 3 ratio. So this is one of the example for similar figures. In the second example, I have shown the two different circles with a different radius. Again, this is also two similar figures. Why? Because of here the shape is same. The radius are different. R1, the radius is not equal to R2 radius. So definitely these are similar figures. Come to the non-similar figures. Give two different example of pair of non-similar figures. So clearly you can see that first one is a rectangle, second one is a parallelogram. So definitely both are not similar figures. In the second example I have taken, one is a triangle, one is a quadrilateral. Again it is non-similar figures. So why? Because of their corresponding sides are different. Their angles also not equal. So here the shape is different. Here it is a triangle, it is a quadrilateral. So this is the best example for non-similar figures. Triangle, equilateral triangle, as well as rhombus. So these are not similar figures. It is a rectangle and it is a parallelogram. So these are the best example for non-similar figures. Next question. State whether the following quadrilateral are similar or not. To check the similarity, it should obey two conditions. First of all, corresponding angles are equal and corresponding sides are in proportion. Come to the sides, corresponding sides are in the proportion. Why? Because of each and every side is twice of this one. So sides are maintaining the proportionality. What about the angles? Here in the second figure, each angle is 90 degree. But this is a rhombus. Opposite angles are equal. Opposite angles are equal. So clearly this is not equal to 90. In the second figure, each and every angle is 90. Here only opposite angles are equal. So that clearly these are not similar figures. Why? Because of they are not maintaining the first condition. This is false. First condition is false. Second condition is true. The sides are in the same ratio, but corresponding angles are not equal. So these are not similar figures. So that's all about this exercise. I hope clearly understood. If you have any questions, you can